It's time to go a step further when it comes to graphing on a coordinate plane. So once again, a coordinate plane is a graph paper where it has the division of the x-axis, the y-axis, 4 quadrants of 1, 2, 3, and 4. We know that we have an ordered pair that's always going to tell us where to put the point inside of parentheses, separated by a comma. My first number is always going to be my x. If it is positive, then I know I'm going to run to the right. If it's negative, I know I'm going to run to the left. My y is my second number. It tells me if it's positive, I'm going to jump up. If it's negative, I'm going to jump down. So when I put a point on a coordinate plane, I'm always going to run, and then I'm going to jump. Graphing the reflection then is understanding what that means when it comes to a reflection. And a reflection in mathematics, when it comes to graphing things, means the exact same thing as it does your and my reflection. Now, the lesson is telling us that by the information given, I can either look at it and tell what the axis is that's being reflected across, or if I'm given a point, that I need to be able to identify and name its reflection point. So that's your entire goal today, is to be able to walk away from this. Now, please pay attention, please follow along, please take notes, please listen to me as I'm going through this, because that's where some of you are still struggling with the idea of listening to me instead of, well, I heard you, and I wrote down what you did on the board, but I didn't listen to what you said, so I really don't understand. Right? I just need you to listen and follow along, and I promise then you'll be able to understand, because I make it as easy as I possibly can. So let's look at the idea of the word reflection. We know what reflections are, but sometimes we don't necessarily apply what we know from life experiences and put it into math. Once again, that's called inferring. So if I look at the idea of reflecting on an x-axis, you've done that quite often. Anytime you've been to the lake, maybe even the ocean, you saw the sunset or the sunrise, depending on which ocean you went to. We have the horizon, right? So in this example, the lake is the x-axis. That reflection of the mountains and trees in the lake is a reflection across the x-axis. Or anytime you look in the mirror, you're looking at a y-axis. Your reflection, your image, is going to be a reflection on the y-axis. So going up and down vertically, we have the same distance and the same image, just flipped on the opposite side. So when we talk about being able to identify reflections, then I have to start with a quick review of, well, what is an opposite number? Because when I look at the reflection point, my coordinates, one number will always stay the same. The other number, my other coordinate, is going to be its opposite. It's going to be flipped. So in other words, one stays the same and one becomes a positive if it's a negative if it becomes a positive, or if it is a negative, it becomes a positive. The opposite is just simply saying whatever the negative is, I make it a positive and vice versa. What it means is, when it comes to opposites, we're talking about numbers that are the exact same distance from zero. This happens to be a horizontal line, so this would be the x-axis. We could do the same thing on a vertical number line. That'd be the y-axis, but we're talking about the exact same distance. So when I talk about -4, then I'm talking about 4 steps from zero. Therefore, if I'm going to move across the x or the y-axis, which on the move across the y-axis on the x-axis line, then I have to move forward 4. So we talk about the idea of absolute value, right? So absolute value, I could do the same thing instead of a number line. I could say, well, I have -4 and +4 and ask, are they the same value? And they are, because whatever's inside the absolute value bars gets written down as a positive number. So the absolute value of 4 is equal to the absolute value of -4, and vice versa. So when I go to plotting then, understanding reflections, there's some information. Once again, I really need you to listen and follow along and understand what I'm saying. It's a video, so pause, rewind, and go back through it anytime you need to. Mark in your book the idea of what a reflection is, and it's saying simply that it is truly a mirror image produced by flipping across a line. Could be that it's a laying flat mirror, so it's an x-axis, or what we normally see, which is a vertical mirror standing up. So it'd go across the y-axis. The key idea to this entire thing is that next set. When a point is reflected, across the y-axis, the y-coordinate stays the same and the x-coordinate reverses its sign. So what that is saying is, if I have something reflecting once again across the y-axis, then I know I'm going to have a point that has to stay the same. So, such as this example, if it's going across the y-axis, the y-coordinate has to stay the same. Notice what happens to the x-coordinates. So if I plot these, then I would have to go and run backwards 2 and then jump up to 1. So I have -2, +1, and its reflection across the y-axis tells me I still have to jump up 1, but now I have to go forward 2. So when I go forward 2 to the +2, notice they are straight across from one another. So once again, it's saying, here's the key idea, that if I'm going to reflect across the y-axis, the y-coordinate will always stay the same. The x-coordinate just becomes its opposite. If it's positive, it becomes negative. If it's negative, it becomes positive. There's another example. So if I know that I have +4, -3, then I know I'm going to go to the right to the positive numbers, 4, right? And then I'm going to go down 3 because it's -3. Its reflection has to be the exact same distance across the y-axis. So the -3 stays the same. But I'm going in the opposite direction. So now I have to plot -4 and still go, -4 and then go down to -3. So the one's going to stay the same, and that's the axis that it's crossing. The one that changes is the one that I'm walking up, down, or forward or backwards on, and I'm just going to go its opposite distance. So that second sentence then, it says when a point is reflected across the x-axis, the x-coordinate now stays the same, but the y is reversed. The y is going to be its opposite. So if I give you a couple of those examples then, I could do +3, -1, and therefore its reflection has to be +3, +1, because if I'm reflecting across the x-axis, the x has to stay the same. So I'm going to go forward 3 and drop down 1 from my first point, but its opposite, its reflection across the x-axis, has to be 1 up instead. So I go over 3 and up 1. Once again, the x-axis is going to stay the same for its coordinate, but the y is just going to be its opposite. Instead of the -1, it's going to be the +1. If I have a -1, +2, and a -1, -2, those would be reflections of one another, because I would go backwards -1 and jump up to 2. And if I jump up to 2, then its reflection has to be the -1 and jumping down 2. So the -1 will stay the same. It's the x-coordinate because I'm going to cross the x-axis. And then my opposite is going to be my y because I'm going up versus down or down versus up. All right, so I would like you to write this down in your book as a note, because this is a mathematical law when it comes to the idea of reflections. Whichever axis you reflect across, that coordinate stays the same. That's the first part of it. Whichever axis you reflect across, that coordinate stays the same. So in my ordered pairs, whichever axis I'm crossing, that number is going to stay the same. Then I simply change the sign of the other number. Right? So that's basically what we have underlined in red and blue as examples if I'm crossing the y or if I'm crossing the x. Whichever axis you reflect across, that coordinate stays the same. Change the sign of the other number. So go move on when you have that written down, but just understand that this point I want to come back to in just a moment. All right, so when we're looking at these examples, it says write the ordered pair that is a reflection of the point -3 1/2 and 2, but then it tells me I want to cross the x-axis. So once again, if I'm going to go across the x-axis, the x has to stay the same. So going across the x-axis, the x has to stay the same, then that means my y has to change. So I'm going to, once again, whichever axis I'm reflecting across, that stays the same. And then the other one, I'm simply going to change its sign. So when I look at the idea that the x has to stay the same and the y has to change, then I'm just going to keep my ordered pair as -3 1/2, which is what they have in their x. And then I have to change the y to its opposite. And the opposite of +2 is -2. So -3 1/2 has to stay the same, but on the y, instead of a +2 where the point is, then I have to drop it down directly below the x, the same amount of distance, so it has to go to the -2. All right, so I want you to see if you can figure out what the ordered pair would be for this example for point Q. What is the reflection of point Q when its location is 1.5, 2 1/4 for its ordered pair? Pause the video and then check your answer. So hopefully you thought exactly as I just went through. Well, if I'm going to go across the x-axis, then my x has to stay the same, and I just need the opposite of my y, right? So whichever one I'm going to cross, it stays the same. I change the sign of the second number. So 1 1/2 has to stay as a positive number. I just simply have to take my 2 1/4 and make that a negative. That's my ordered pair for the reflection of point Q. So like with all of our other math, we are going to have word problems or story problems that we have to be able to use our lesson on. So once again, paying attention and following along and making sure we understand what we're doing. So in this example, they give us a drawing of a square, and it says that Kendall is building a square fence. She places fence posts at the locations located on the grid. What is the reflection of the post that reflects point S at ordered pair of -2, +2 across the y-axis? So I'm going across the y-axis, right? That's my vertical axis. So I know that I have to square equal distance. I'm reflecting across the y-axis. And my rule is that I keep the coordinates of whichever one I'm crossing, and I change the opposite for the second one. So in this case, since I'm going across the y-axis, then my y coordinate has to stay the same. And then my x, I just have to write its opposite. Therefore, as they're showing you, if I keep the y, it's going to remain as a +2. But instead of having a -2 for the x, I'm going to do its opposite, which is a +2. So they tell you that the reflection of point -2, +2 would be a +2, +2. All right, so I want you to apply that information to the check and do it on your own. Pause the video, come back and see how you did. So hopefully you, if you were confused, you went back and rewatched what I just explained, but it's the exact same process, kind of basically the exact same scenario, right? Just different numbers. So we're told that we have a post at 10.2 and -5.3. We're going to go across the y-axis. And if I'm going across the y-axis, then I have to keep the coordinates, of the y. So my -5.3 has to stay as -5.3, so I can cross the y-axis. But instead of having a positive 10.2, I now, instead of going forward, I have to go backwards, and I end up with the opposite, which is -10.2. So that reflection would be the ordered pair of -10.2 and -5.3. All right, so let's continue on. And we identify now which axis we're going across. So previously we were told which axis we're going across. And now by having two ordered pairs, I have to be able to tell which axis I am crossing. And this is going to take us back to the idea of that I said I was going to come back to. So they give you what is called prime notation. Prime notation is simply showing you with symbols and letters what a reflection is, or which one is a reflection. So the note from the book on that first page, it says, in the coordinate plane, when you reflect a point across a line, you name the reflected point using prime notation. In the figure, the reflection of point A at -4, 0 across the y-axis is the reflection of 4, 0. So what they're showing you is that when I have the point, it's just the A by itself. When I'm doing prime notation or saying the reflection of it, then I add that little single quote mark. So on your computers, if you look at your keyboard, then it's the very first the little quote, single quotation. That's what it's called, single quotation mark. So all that is saying is instead of having to write out the words, this is a reflection of this, it says the reflection of. So when I'm looking at it and I'm saying the point of reflection of -2 3/4 at -4, is the result of reflecting. So we're just saying that this is my reflection point. Now, we could also have this indication where I do the double quotes. And what that is saying is the reflection of a reflection, right? So I could, let's, for example, cross the y-axis. So I could do a reflection and go across the y-axis. Then the reflection of the reflection means I want to cross the y-axis, and now I have to go across the x-axis. So the reflection of a reflection means I have to do 2 steps, right? If I'm in one quadrant, then I'm going to go basically to its diagonal quadrant. So if I'm in quadrant 1, I'm going to go down to quadrant 3. I'm going to cross the y and then go down across the x. It's just doing 2 reflections at one time. You might see that on your assignment. But in this example, it's saying that this is the result of, right? So the reflection is a result of reflecting point A. Which axes did we cross? Did we cross the x-axis or did we cross the y-axis? And these should be pretty easily, I hope. But they say, well, if you get confused on it, you can use the table, all right? So all the table is saying, if I put which points that I have. So the point itself, its x coordinate versus its y coordinate, right? And then the reflecting point, which is the A with a single quotation. So when I have the x coordinates for the point, then it's at positive 2 3/4, and its y coordinate is at negative 4. When I look at the reflecting point, then I see that I have a negative 2 3/4 as the x-axis, and its y is negative 4. So once again, when I look at my rule, whichever axes we're crossing, that number is going to stay the same, and the other number, the other coordinate, is going to be its opposite. The one that stays the same, right, is going to be the one that we're changing. It says that the x coordinate are opposites and the y coordinates are the same, and therefore point A was reflected across the y-axis. All right, so see if you understood that one. Check that one down below. Come up with your answer as which one we are going to cross, and then see how you did. So hopefully you just looked at your 2 different points, right? When I have the reflection point of M, and I look at the x's, I see a positive 2 1/3 and a negative 2 1/3, and those are opposites. I look at the y's and I have negative 1 and negative 1, right? So my point of reflection for 2 1/3 and negative 1 is going to be the negative 1. So my reflecting axis is going to be the y-axis. Hopefully that's not too difficult being able to identify. It's just which one doesn't change, right? So on your assignments, you're going to have questions 2 through 10, and you're going to have questions 12 through 16. Now there is plenty of time because we have math for an hour and 15 minutes, right? And I took about 20 minutes to go through the video. But if you do have questions, you get confused, if you've taken your notes, come and ask for help. If you haven't taken your notes, you haven't followed along, then I'm going to make you go back and rewatch the video and take the notes, because that's how I'm teaching you, is by you taking the notes, following along and listening.